Hi, welcome to another mini lecture. Today we have two topics: solving an exponential equation by finding common bases in linear exponents, and another one similar to this, solving an exponential equation by using logarithms and exact answer in logarithmic form. So it's going to be simple. Many of these exercises go back to a lecture we had a long time ago. We said let's memorize all numbers of the form a to power of b below 1000. That's gonna do all of this. Perhaps just up to 100 will be enough. So what do we do here? Numbers on the two sides are different, but they are powers of the same base. So 27 is 3 to power of 3, excuse me. So 27 is 3 cubed and 81 is 3 to power of 4. The whole problem revolves around remembering these facts and then moving based on that. So I write the left hand side, instead of 27 is 3 cubed to power of minus x minus 4, and right hand side is 3 to power of 4. So remember that if you have a to power of b to power of c, it's going to be a to power of bc. So on the left I can write as 3 to the power of 3 times x minus 4, and on the right hand side I have what I had before. Now all I have to do is to equate the two exponents. The bases are the same. That's the whole idea here. We have common bases. So common bases, it means all that's left is for the exponents to be equal. So 3 times x minus 4 is equal to 4. So 3x minus 12 is equal to 4. So 3x is equal to 16, and x is equal to 16/3. So that was that problem. So what do you think we should do here? What is the common base here? Of course, this one can be written as 2 cubed to the power of minus x plus 4, and this is 2 to the power of 4, and we see that the exponent is 3 to the power of times minus x plus 4, and the right hand side is 4. So minus 3x plus 12 is equal to 4. So minus 3x, I subtract 12 from both sides, and so x becomes 8/3, and so on. So this one will be 2 to the power of 12x. As it is, we don't have to do anything to it. 64, we need to remember that it's 2 to the power of 6, 3x plus 4. So on the left hand side the exponent is 12x, on the right hand side it's 6 times 3x plus 4. Instead of multiplying, it's better to divide by 6 here to our numbers become smaller and chance of mistakes will be less. Now I subtract 2x from both sides, so I'm left by x here, and bring the 4 to the other side, so I get x equal to minus 4. Okay, this was a few problems of this type. Well, what if the bases are not common? So all these three problems we had here, we essentially got lucky. 27 and 81 are powers of the same base. 8 and 16 powers of the same base. 2 and 64 powers of the same base. But that's not the case for 11 and 3. So what do we do in this case? Well, simplest thing to do is apply logarithm to both sides. You can use either log base 10 or log e, and the answer has to be written accordingly. So on the right hand side I write logarithm of 11 to the power of minus 2x, and on the right hand side logarithm of 3 to the power of minus x minus 2. Now I bring let's remember rule of exponent. Logarithm of a to power of b was b logarithm of a. So we are going to use that, and on the left hand side I'll have minus 2x logarithm of 11. On the right hand side minus x minus 2. I need to have a parenthesis here, logarithm of 3. Just to be clear, let's put both sides. Let's emphasize, let's put a parentheses. It never hurts. And if you have multiple items added and subtracted, you do need that parentheses. What now? The important thing is now to focus on x. We want to capture x. So let's bring everything that has x to one side and see what happens. So I have minus 2x logarithm of 11 minus x logarithm of 3 comes to this side, becomes plus x logarithm of 3, and we have minus 2 logarithm of 3 left. Now I factor my x. I'll have minus 2 logarithm of 11 plus logarithm of 3 is equal to minus 2 logarithm of 3. So x can be written as minus 2 logarithm of 3 over minus 2 logarithm of 11 plus logarithm of 3. This is the final answer. You can modify it slightly if you want to write it in the other form, like taking the coefficients inside and rewriting it, but that's optional. Not much is going to be gained, nor is it going to become all that nicer. Just as a indicating what is meant by that, this is logarithm of 3 to power of minus 2. Denominator is logarithm of 11 to power of minus 2 plus logarithm of 3. So we can write this as logarithm of 3 to power of minus 2, and you can apply rule of logarithm. This is logarithm of 3 times 11 to power of minus 2. So that, if it appeals to you more, you can use this form and perhaps other modifications. How about here? Same idea. Just apply logarithm. It doesn't matter, logarithm base 10 or base e. We'll have minus x minus 9. So we'll be taking logarithm of both sides. So minus x minus 9 logarithm of 17 is equal to 2x logarithm of 5. Same idea again, focus on x's. Expressions involving x should come to one side. So here I have minus x logarithm of 17 and minus 2x logarithm of 5. Minus 9 logarithm of 7 is going to go to the other side, or 17, excuse me. It becomes plus 9 logarithm of 17. Now factor your x. Minus logarithm of 17 minus 2 logarithm of 5 and 9 logarithm of 17. So x is the ratio of that expression over minus logarithm of 17 minus 2 logarithm of 5. It says exact answer. We don't need a calculator, neither one is allowed, nor is it that if you use it your answer will be accepted, because it's going to be an approximate answer. So exact answer, you can write it in a variety of form, but this is good enough. So what did we learn? Solving certain exponential equations. If bases are on the two sides have a common base, then we get a problem that can be done by this technique here. We write both sides to the same base, multiply the exponents, and set the exponents equal and solve the resulting equation. Sometimes we don't have a common base, in which case we just apply the logarithm and proceed. Of course, this method could have been applied here as well, but in these problems the expectation is that you give a rational answer at the end. Okay, so until next time, good luck and God bless.